What was our learning focus? What were we learning about, Lana? Fractions. That's right. And fractions are parts of a whole, and you guys built fraction posters, and you played a fraction matching game. Now, are you ready for a STEM challenge with fractions?
Yes.
Awesome. Now, your STEM challenge with fractions is going to be to build a fraction. This is the book we read, and we talked about putting groups into fractions. Now you guys are going to build objects from fractions. And to get started, we're going to make a plan, okay? So I want you to think, you know what fractions are now. You know how to draw and label a fraction. We have a STEM planning packet. I would like for you to please write your name right on the top of this. I love the way you're waiting so nicely. Write your name on the top half. Thank you. You're going to write your name at the top.
What's on the bottom of this paper?
On the bottom, it just says the date that they made this.
Oh, no.
So let's see your name. That's a, what do you see? What illustration?
Pizza.
A pizza.
Just a pepperoni pizza.
Did they cut a fraction of that pizza out?
Yep. Just
What fraction do you think that is? Can anyone identify what fraction this might be? I like the way you raised your hand quietly. What do you think?
1/5.
1/5. Let's see. Let's count the pieces. 1, 2, 3, 4, 5, 6. I saw you correct your mistake. Awesome. You changed your mind, didn't you? So it's 1/6. It's 1/6. That's probably hard to see. Let me make that black. 1/6. Good for you. I bet you were thinking, did you count these 5? Yeah, and then you realize that's part of that whole, right? And that's why it's 1/6. Good job. All right, your name is on it. Now this first page is just going to show your mom and dad what cool things we talked about this morning. And then you're going to turn to the back. And it says, what is the problem? State what you need to do in your own words. Let's see, you found it, you found it. We're good? Awesome. Okay. Let me explain the problem with you, because you always need to know your STEM problem, okay? We read a special story about field day, and there were teams broken into fractional parts. We read that story this morning. Do you remember that? When they broke into 4 parts, what were they breaking into parts for? What were they going to load into? Do you remember? Which race was the 4 parts?
Well, the 4 parts was like the 4 parts.
You want me to give? Do you remember?
The canoes.
The canoes, that's right. And the 4 parts were 3. There were 3 in 4 parts because there were 12 in all. Good remembering. Okay. Some of the teams were made up of half of the campers, some were a third of the campers, and some were a fourth of the campers. Breaking the teams into equal parts made the teams the same. We really talked about that. Fractional parts have to be the same. So here's your challenge. You're going to design and build 2 objects using basic shapes, showing 2 different fractions. Okay, so let me show you. Who can tell me a basic shape? What's a basic shape, do you think, Lana?
Circle.
You are right. Good thinking. Leland, what do you think?
Triangle.
A triangle? Maybe you could break it into a triangle into basic fractions. What do you think?
Diamond.
A diamond. A diamond. That's kind of tricky for me to build. There you go. What do you think?
Square.
A square? What should I be careful about when I draw this square? What makes it a square? 4 what? The sides in a square should all be what? Round? How's a square different than a rectangle? How about that question? Is a square different than a rectangle? How's a square different? Show me a square. I know that you know this. That's a square, right? How is that different than this shape? What's special about these sides? They're all the
Same.
Yes, you got it. They're all the same. Okay, so you're going to have to be really careful. We measured this morning with rulers and everything. There's one more basic shape we talked about. Do you know what it is?
Rectangle.
Awesome. Draw a rectangle in the air, everybody, so I know you're thinking what I'm thinking. Rectangle. Good job. All right. So those are the shapes that you're going to use in your STEM challenge. So your STEM challenge is to build one of those shapes and break it into fractional parts, okay? You're actually going to build the shape 2 times. So it says build 2 objects using basic shapes showing 2 different fractional parts. You might do 2 rectangles. You might do 2 squares, 2 diamonds, 2 triangles, 2 circles, okay? And you're going to break them up into 2 different ways. So if I did 2 circles, I could show 1 circle being half, 1 circle being, what would that be? Fourths. Good thinking. If I did 2 rectangles, I could show 1 being, what's that broken into? Thirds, right, and another way. Good job. So here's your criteria. Think about this because you're going to build a fraction. You're going to build 2 fractions using materials. You have to have 2 of the same objects. We just talked about that. You have to have 2 circles or 2 triangles or 2 diamonds representing 2 different shapes. Here's the tricky part. It has to stand by itself. That's been a big challenge for everybody. So think about that as you're building your fraction. It has to be attractive. Do you know what that word means? Attractive? What do you think that means?
Like, a lot of stuff come to it.
A
Like
l-
it attracts stuff.
It attracts stuff. That's right. You know what? If something attracts something, it looks good. Yes.
Like dog food attracts a dog.
Dog food attracts a dog, right. So attractive means it looks really good. It's got to be attractive. And it's got to be colorful and creative. And you're going to label and write the fraction you're showing as a number. We practiced that this morning. So you're going to be labeling the fraction. And you're going to compare the 2 fractions. We're going to do this through a discussion. We're going to talk about which piece is bigger than the other piece. Like if I was comparing 1/2, think of this as a pizza. And I'm really hungry. Would I want to eat half of the pizza or 1/4 of the pizza? Which is a bigger piece of pizza?
1/2.
1/2. You are right. 1/2. So we're going to be comparing fractional parts. So what's the problem? What's the problem? Do you see what your problem is? What's your challenge? Can you say it in your own words?
We have to make it stand.
That's one of the criteria, make it stand. What's the problem? What are we going to work on?
Making it into halves.
Okay. What do you think?
We have to use 2 shapes.
Good. All of your ideas are great. Let's put it together into a problem together. So we are going to build 2 shapes and show 2 fractions. Is that the problem?
Yes.
Yep, that's our problem that we're going to solve. We're going to build something together. So when we write a sentence together, boys and girls, what kind of letter should we start with? Always? You are right. Get your pencil in your hand. Let's write this problem together. Let's start with a capital, and let's write the word we. Who can spell it for me? Everybody, spell it out loud.
W-E.
Good. We. The problem is what we need to do. We are. That's a good sight word. What does R end in? What letter? You can tell me out loud. E. Good job. We are going. What ending is in that word going? Yes.
IND.
I-N-G. Good thinking. We are going. Well, I don't want to write the word going because listen, The question says, what do you need to do? So how should we answer that?
We need to.
We need to. You all have erasers. Do you agree that we should write we need to?
Yeah.
Yeah, I agree. So you can erase we are. That was a good way to review that word are, I guess. We need to build I love the way you're spacing your words. Great job. Can I help you back up? Oh, good job. Now you write the word need. Liza, you're doing great. We need, how about I write need and then you write the rest. We need, there you go, your turn. Two. Good job. We need to build what? How many?
2 fractions.
Okay, we need to build 2 shapes and show 2 fractions. We need to build, I'm going to write the number 2. 2 shapes, and when I write the word show, what chunk should it start with? Show. Yes. S-H. Shoes from our chunk chart. We need to build 2 shapes and show what? Show 2 fractions, 2 different fractions. We need to build 2 shapes and show 2 different, that's a long word, different fractions. That's a lot of writing. I can help you, Isa. You're doing great. What goes at the end of my sentence?
Period.
Awesome, thank you. That's what we need to do. That's our STEM challenge. You guys are doing great writing. Awesome. We need to build 2 shapes. What word are you on? And good. Oh, excuse me. Good writing, boys and girls. Who asked me that? Yes, you may. Right back there, honey. Thank you. All right, now, some of you are all ready to go on to the next question. And if you're not, you're finishing up your writing. And I want you to be thinking, it says, what shape do you think you will use? Well, you're going to be working in groups. You're going to be working, this will be a group of 3 people. You 2 will work together. You 2 will work together. And this group of 3 will work together. So what I want you to think about is, what shape do you think you'll use, and what 2 fractions will you use? Would you talk to your group right now? Talk about what your ideas are, what shape you want to use.
No. So if we're talking about the 3 states of matter, are you more like a solid right now or a liquid?
Solid.
Now, I want you to make yourselves a liquid.
I'm sorry, stop moving.
Okay. Can you guys put that in your brain and remember it? All right, have a sit on the floor.
Okay. Mrs. Hash and I have something so exciting for you to do today. I can't wait for you to see. So, what we're going to do today is we are going to make an insulator. So, I want you just to think for a second, and I want you to think, okay, insulator. Maybe I've heard that word before. And I think insulator. Where have I ever heard or seen an insulator? And then I think, my cup is an insulator. Mrs. Hash, what else do you know that's an insulator?
Well, this winter when it was really cold and I had to go out to bus duty, what do you think I put on? Why?
It was cold.
It was cold. Well, what did that coat do for me?
Keep you warm.
It kept me warm. It insulated me. It kept my warmth, because I'm warm-blooded, in, and kept what out? The cold. That's an insulator.
And my cup is insulating right now. I have water in here. And I want to keep my water cold. So I have an insulator. I want you to just think for a second. Based on the examples we gave and what you already know about insulators, what's an insulator? Turn and talk. Turn and talk to each other. What's an insulator? Can you think of an insulator that you might have?
Ice cream simulator.
An ice cream insulator.
Chocolate insulator.
Do you ever go to the pool or the beach or somewhere?
Yeah.
And your mom packs a cooler? That's an insulator. It keeps what cold inside?
Warm.
Oh, you have things that you want to keep warm inside of your cooler? Oh, okay.
The freezer.
And yesterday I went to Chick-fil-A, and when I got this thing, my
Keep
cup
it
wasn't
cold.
there. And the difference was my cup and the Chick-fil-A made a stack. And my cup, oh my God, it was more than just a wax paper.
5, 4, 3, 2, 1. There were a lot of great conversations about what an insulator is, and some of you were giving examples of insulators that you have in your life. I actually heard this group right here talking a little bit about insulators. What were you talking about? Can you share with us?
When Mrs. Hash went to McDonald's, I think it was Coco, that when she drove to her other school to work in her office, her cup was wet. Then the next day she went to Chick-fil-A. Then when she went to the other school again and to work in her office, it wasn't wet, the cup.
And what kept it insulated? Do you remember?
The cup, because it was not made of wax paper.
What was it made of? Do you remember? No?
Styrofoam.
It was made of styrofoam. Styrofoam is an insulator. I heard somebody else talking about what they use when they go to the pool and their mom puts drinks inside of it. Their cooler, their cooler keeps things insulated. So what we're going to do today, friends, is we have for you freezer pops, ice pops. But here's the tricky part. What we're going to do today is we're going to insulate our freezer pops, and we're going to put them in the freezer. And then tomorrow we're going to take them out. It's in a special place in the cafeteria. And we're going to take them out tomorrow, and we're going to put them out on that blacktop. We're going to set the timer for 10 minutes, and we're going to see whose freezer pop stays frozen the longest. So your job today is to make a really great insulator so that your freezer pop stays frozen. Okay. Do you have something to say, friend?
I have a question.
I hope I have an answer. Go ahead.
Are we going to be working in groups?
We are going to be working in groups, 2 or 3. So today, we have a story for you. And how many of you are familiar with Frog and Toad? Thumb up. How many of you love Frog and Toad? Yeah, I love Frog and Toad too. So we're going to read you today just a little excerpt, just a little snippet from the story of Frog and Toad all year. Okay, we're not reading the whole book today, just a little piece of it. Mrs. Hash actually found this little piece. You know what it's about? Ice. Yes, it is. Okay, are you ready?
Oh yeah, I've read this book too.
It is silly. Are you ready?
Yes.
Okay. Ice cream. One hot summer day, Frog and Toad sat by the pond. I wish I had some sweet, cold ice cream, said Frog. What a good idea, said Toad. Wait right here, Frog. I will be back soon. Toad went to the store. He bought 2 ice cream cones. Are you thinking right now? Are you thinking? I'm already thinking there could possibly be a problem happening in our story, right? Turn and talk. What kind of problems are we seeing right now?
So we're working on how can we make the ice pop all cold and try to make it freeze. And it's starting to get very cold. Since they're liquids and we just wrapped it, and then we could just freeze it longer because the padding.
Ready? Here we go. All right. Wow, it worked pretty well. Okay. Now, all right. So, if you have to improve that boat, what would you do?
Cut a little bit off the propeller so it'll be faster because it hits the bottom of it.
So it's making contact. So is it too long? Okay.
Well, if you let it go, watch.
All right. There we go. But when you immerse it into the water, you notice that it was actually hitting the bottom. Right. Okay. Oh, another experiment we did was what? After that, windsurfing. Okay. So, and one of the books we read with that was The Boy Who Harnessed the Wind. Okay. So we learned quite a lot from that. Who has their windsurfing experiment that they want to share? Let's see yours, William.
Honestly, I don't think it's gonna be able to reach.
That's all right. Okay, tell us what just happened there.
I think I should have taped it instead of sling cardboard.
Okay. So you notice the material is pulling apart. Okay, how can you improve that boat? What could you do?
Using plastic or taping the cardboard.
All right. What suggestions do you have for him?
Use a thicker rubber band because that one's too small and it can't get enough potential energy to actually move the boat.
Do you hear what he just said? Okay, says he gave you advice. He said to use a thicker rubber band to store more potential energy. What about the propeller, Arjun? What suggestions would you give him?
Maybe don't use cardboard, because if you use cardboard, all the water can go into it and it can go apart.
Okay, so because cardboard is very what?
It's very soft.
Soft, it absorbs a lot of water, it becomes very mushy in the water, and then it falls apart, right? So what would you do differently if you have to improve that? Okay, what part of STEM is that? What part of STEM is you working on right now?
Science with the potential energy.
Okay, and the engineering part, what would you do?
Technology and engineering with it.
Okay,
To create a new propeller.
create a new propeller, right?
Which would be
Okay, let's see what you guys